Okay, so today we're talking about radical equations. So this is equation containing a radical. So that means that it's got a square root, a cube root, a fourth root, etc. in it. And it can be converted to an equation that doesn't contain a radical by raising both sides of the equation to the right power. So this is kind of a series of steps to do. Number one, we're going to isolate a single radical on one side of the equation. Sometimes there are two. So if we only have one radical, it's pretty simple. We put the radical on one side. Then we're going to square both sides of the equation, or raise both sides to a power that's equal to the index of the radical. The index is this number right here. So what we can do is, if we have a cube root, of course, then we would raise this to the cube. This we'd take to the fourth power, etc. Then we clean that up a little bit, and if we still have a radical, because sometimes there's two radicals in the equation, then we have to go back and start over. And then we keep doing this until there's no more radicals. We solve the resulting equation, which can sometimes be quadratic. So sometimes there might be factoring involved or something else. And then all solutions must be checked. Now, I've not been a real stickler about you guys checking your solutions, but in radical equations, you must not skip that step. That has to be done. You have to check, because if you don't, there's sometimes what's called extraneous solutions that don't quite work. Because you're squaring something, it could have actually been a negative square root. And then when you squared it, it just doesn't work. So you must actually do the check part. So do not skip this step. There's supposed to be an exclamation point, but it wasn't. So let's do this radical equation and you'll see. So let's start by step one, isolate the radical. So we do the radical. To isolate it, we're just going to subtract 5 from both sides. Step two, in this case, it's the square root, so we square both sides. So x plus 7 equals x squared minus 10x plus 25. Don't forget how to do this. Don't kill puppies. Remember, you have to have this middle term. Then no radical remains, so we continue. Now we solve the new equation. So this is quadratic, so I'm going to put everything on one side and 0 on the other and see if I can factor it. So negative x minus 7 minus x minus 7. So 25 minus 7 is 18. So let's see if this is something that I can easily factor. So 2 factors of 18, whoops, that's not 9, that's 11, I'm sorry, 10, that's a negative 10, so that's 11, which is good. So 2 factors of 18 that add up to negative 11, so that would be negative 9 and negative 2, whoops, forgot my x. So now I use the zero product properly, x minus 9 equals 0, or x minus 2 is 0, so x is either 9 or 2. Now, I have to check because I can have that extraneous solution. So I have to check. So the square root of 9 plus 7 plus 5 equals 9. Is this true? So the square root of 9 plus 7 is the square root of 16 plus 5 equals 9. 4 plus 5 equals 9. Yes, that works. So then let's try the other one. So this is definitely a solution, so we're good there. So the square root of 2 plus 7 plus 5 equals 2. So now we have the square root of 9 plus 5 equals 2. 3 plus 5 equals 2. What? That's not correct. Now, negative 3 does, but when we squared it, we took that out. We made that a positive 3. So that's how that happens. So you can see if that had been a negative square root, this would have worked. But when we did that squaring, we took out the possibility that it was a negative. So it does not work and it's not correct. So 2 is, even though we did everything correct, is not a solution. It's called an extraneous solution. So you have to check these answers. So the answer to this is x equals 9. That is the only thing that makes that true. So even if you do absolutely nothing wrong, you can get an answer that does not work. So we can also take a look at the calculator using the intersection method. So remember, you could always check your answers. So we have, let's just clear that easier. The square root of x plus 7. Then we use the up the arrow to get away from not being under the square root anymore. Plus 5. And then here, I'm just going to clear this, and this is going to be an x. So now I have these. So now I'm just going to graph this. I'm just going to zoom it to standard and see what it looks like. There's that one. Oh, I can see it. That's good enough. Okay, so calc, intersection, first curve, second curve, guess. Okay, let's get up there. Sometimes it takes a while, right? Well, we know it's 9, so. Okay. The guess is x equals 9. Done. And so that's all we have to do about that. So we checked it. Is it 2? Does it intersect at 2? No, not even close. They're completely different at 2. So it's not correct at 2. So let's do this radical equation by hand. Check our answer using the calculator. This has 2 radicals in it, so we have to be careful. We're going to start by, of course, isolate one radical. Okay, this is already done. Number 2, square both sides. So 2x plus minus 5 equals, we have to square this. 1 plus the square root of x minus 3, whole thing squared. Now this one cancels, but this one doesn't. So 2x minus 5. Now remember, we have to use the first term squared plus 2 times the first times the last plus the last term squared. So this becomes 2x minus 5 equals 1 plus 2 root x minus 3. Now this comes out, x minus 3. All right, so remember, if a radical remains, we go back to step 1. Now we have to isolate the radical again. So let's isolate the radical. I'm going to start by subtracting 1, adding 3, and subtracting x. So subtracting 1, subtracting x, and adding 3. So let's see what we get. 2x minus x is x. Negative 5 minus 1 is negative 6, plus 3 is negative 3, equals 2 times the square root of x minus 3. So now I have to divide 2 from both sides. And I have x minus 3 over 2 is equal to the square root of x minus 3. Now I can move to step 2 and square it again. So now I have x minus 3 squared over 4 equals x minus 3. Still some more cleanup. So let's see, I can actually multiply both sides by 4. Put that back over there. X minus 3 squared equals 4x minus 12. So let's clean this up. X squared minus 2 times 3 times x plus 3 squared equals 4x minus 12. Again, we have a quadratic, so let's put everything on one side. So solve equation. 0 on the other. So x squared, we're subtracting 4x, we're adding 12. And so can we see what this is? Yes, we can. 3 and 7. Minus 3x minus 7x, that's negative 10. Negative 3 times negative 7 is positive 21. So x is either 3 or 7. Again, is it? And so this is where we have to stop, and we have to go, let's look at our original equation, which was the square root of 2x minus 5 equals 1 plus the square root of x minus 3. We have to plug both of these in to make sure. Could be one of these is right and the other one's wrong. They both could be right, or they both could be wrong. So we have to check. We can't forget. So the square root of 3x, the square root of 2 times 3 minus 5 is equal to 1 plus the square root of 3 minus 3. So this is the square root of 6 minus 5 is equal to 1 plus the square root of 0 is 0. So this is 1 equals 1. Yes, that one's good. So let's try the other one. The square root of 2 times 7 minus 5 is equal to 1 plus the square root of 7 minus 3. So let's see, the square root of 14 minus 5 equals 1 plus the square root of 4. The square root of 9 equals 1 plus the square root of, well, square root of 4 is 2. Square root of 9 is 3. 1 plus 2 is 3. Done. So now both of these are valid solutions to this equation. So x is either 3 or x is 7. We'll make this correct. Now we can look at that again. And, y equals, okay, so this side is 2x minus 5. And this side is 1 plus, under the, did not, oh no, come on. 1 plus the square root of x minus 3. So let's take a look at this. Let's just graph it. There's one of them. Ooh, that's hard to see. So let's see if we can't zoom that to where we want to be. We want to be somewhere between 3 and 7, I think. So we can see both of them. Again, still a little bit hard to see, but we can start to get it. So let's try to get at least one of them. Let's do this intersection. Well, we have our intersection at x equals 7. Okay, so we need to find the other one. So we're going to need to zoom back out. Let's zoom out a little bit farther this way. Oops, no, stop. And down a little bit. And we can probably find the other one. Let's see if we can find the other one. So let's try it. Intersection, first, second. I know I'm close to 3, so let's hope that works. I still got the x equals 7. Okay, let's see if we can find the other one. So let's try zooming in again. Oh, here we go. Let's try zooming where we want to. We want x equals 3, so let's just go 2 to 4. Let's see what we get. I know it's more than 0, so let's see what we got. I know it's 3. Oh, there it is. It's right there. Okay, so let's see if we can find it now. So our intersection, first curve, second curve, my guess. Hey, look, intersection x equals 3. Sometimes they're hard to get to. Okay, sometimes it's faster just to do the algebra. Okay, so let's solve this radical equation. So again, we need to isolate one radical. So when there's 2, you want to start by isolating, hint, isolate one with 2 terms first. So you want 4x plus 1. Let's add the square root of x 6x to the other side. So that's the square root of 6x minus 1. So we're going to square both sides. We get 4x plus 1 is equal to first term squared minus 2 times the first times the second, that's just 1, plus 1 squared. Okay, now we clean it up. Okay, so that's the square step. Okay, now we still have a radical, so let's clean this up a little bit. That's the square root of 6x, so that's 6x minus 2 root 6x plus 1. So we still have a radical, so we go back up to isolate the radical again. So let's clean this up, isolate the radical, subtract 6x from both sides, subtract 1. And we end up with negative 2x equals negative 2 times the square root of 6x. So let's divide both sides by negative 2. And I have x equals the square root of 6x. So now, square again. X squared equals the square root of 6x squared. So this becomes out, so then solve the resulting equation. So now we have 6x equals x squared. Well, we can do this, put everything on one side, 0 on the other, right? X squared minus 6x. We can factor out an x. So x is either 0 or 6. And then, of course, we check. So let's check these two answers. We have the square root of 4 times 0 plus 1 minus the square root of 6 times 0 equals negative 1. So let's see, this is the square root of 1 minus the square root of 0 equals negative 1. 1 minus 0 equals negative 1? No. So 0 is not a valid solution. Let's try 6. The square root of 4 times 6 plus 1 equals the square root of 6 times 6, or minus the square root of 6 times 6 equals negative 1. Well, this is the square root of 25 minus the square root of 36. So this is 5 minus 6 equals negative 1. Yes. So 6